Hello, it is time to start with Study Unit 3 now. During Study Unit 2, we did a lot of mathematics. We analyzed code to check their complexity and in terms of their running times. But now we are taken back to the world of programming, and especially what this course is all about, data structures and algorithms. We start our quest to better understand data structures here with arrays. Now, this study unit should not contain new information, but it's a different way of thinking, and it is preparation for study unit 4 on linked lists. It is very important for your understanding of study unit 4 to really deeply understand all the aspects presented in this study unit. So you can, once again, I think it's best if you print the slides, listen once to the video, and make notes on the slides according to the video. So let's start. This work is covered in chapter 24.1, section 1 in your textbook, but we provide a much simpler version here. In a way it's simpler, and in a way it's more complex. We have higher goals than the textbook's example in chapter 24. I strongly suggest that you do not get lost in the code of chapter 24, but rather study the examples here. Remember, all the code we use is in the folder of code used in the study unit on your Ifundi site. So let's quickly look at the aim of our work. The aim of our study unit is to create a generic array that can be sorted. Now, generics is part of your prior module, and it is discussed in chapter 13 and 19 respectively. But you don't have to go back to those chapters. You can only follow the code and the explanation here. Everything you need to know about generics is covered in this example explained in the study unit. Of course, you can go back to those chapters as you want. I'm going to move myself around a bit here so that I do not get in the way. The big picture is more important in this study unit than the Java. The big picture will take you forward in your career. Sometimes you wonder, why didn't you study at a college or didn't do a quick course on internet? Why did you enroll for a university degree? This is the reason, so that you can write very good programs to be used by other programmers, not end users, programmers. You are now on the next level. You create programs to be used by other programmers. In a way, you are extending the functionality of Java. Now, why would we want to do this? The answer is productivity or reusability. We want to create code that is reusable for other people so that they don't have to reinvent the wheel every time. In this case, we want to develop an array class which is so good that every time any programmer wants to use an array, they would rather use our class than the basic built-in array in Java. But it's not only about arrays, it's about the principle. It's a principle of designing code that is reusable by other programmers. So we demonstrate this with the array class just because it's in your frame of reference, and we demonstrate it with the circle class and the shapes hierarchy, which you have experience with in study unit 1. So do not continue to the next slide if you do not understand all the code of study unit 1. It's a good idea to see how we have changed the code in study unit 1 to be where we are, because you can know already now that you have to do the same to your cell phone users as an assignment at the end of this study unit. Very often the students battle to understand where we are going to. What's our end destination. And therefore we start with the driver program. You will see, if you compare this code to the code of study unit 1, there's no array, but there is an object of the class myArrayList. This is the class we are developing in the study unit. And you will further see, if you remember generics, we tell myArray what class to use in the array, and we use the superclass. And we create a new myArrayList. This is now the test class we call the driver in study unit 1. And we do exactly what we did in study unit 1. We create a lot of circles, we create a lot of rectangles, but now we add it using our own add method in an array. Can you see the difference? There's no square brackets any longer. The array we are adding it is not in the driver class. The array actually is in the myList class. The myList class forms a nice interface for programmers instead of the basic Java array. Let me repeat that. The myList class replaces the need to use an array for the typical programmer, the programmer who created this class of circles and rectangles. No longer uses the Java array type. That programmer uses our class, the class we develop in this study unit called myArrayList. That programmer has to do a few things to make use of this program, or this extension to Java we are talking about. You should tell us for which class you will use it in those smaller than and larger than sign brackets in line 4. We will get back to what is needed to use our class later, but just a few more notes here. Note we sort this array. Isn't that fantastic? We create in our array list such functionality that the user can not only add things, he can sort it. Now this should heighten your curiosity. How does the sort array method here, the sortlist method now, how to sort these elements? That's a good question, which we will answer later. We also have a ToString. Can you see here's an implicit call to the ToString? That implicit call to this ToString is also a form of polymorphism. This whole story is the same ideas of polymorphism than before, but later about that, later more on that. Our big idea. You study data structures and algorithms. Let's first focus on the data structure. What is a data structure? Now, the basic format of a data structure is something that stores data in the memory of a computer. Something that stores data in the memory of the computer. You know that the most simple data structure is a single variable. If I say int a equals 4, that 4 is the data, and the a is the data structure in which it is stored. Now that's fairly primitive. I can have a better data type or data structure, which we call objects of classes. I can even have a better one, which is an array. Now, we are not using only the array in the book or in Java. We are improving, and this is the aim of this study unit, we are improving the functionality of arrays by creating our own class for an array. Sometimes this is called a wrapper class. We will come back to the idea of a wrapper class later. One last idea before we start is that an array is a type of list. It's a group of items listed together. In study unit 4, we do another totally different type of list, a list you've never seen before, a linked list. And all the work in this study unit is carefully chosen to prepare you to understand our implementation of the linked list. Okay, you are studying data structures and algorithms. What are the algorithms all about? They are typically only the algorithms needed to manipulate the data structures. Now, if we want to say which algorithms we are needed to manipulate a list, obviously there's a standard list of them, like retrieve an element. What would the user of our array list want to do with it? We already talked about sorting it perhaps, but before that he wants to add information to the list. He wants to retrieve information from the list. He wants to delete information from the list. He wants to find out how many elements there are in the list, whether a specific element is in the list or whether the list might be empty. Now you can indeed add your own here. We added our own here. We say he wants to sort the list. Sort according to what? That is still the question that's unanswered. But if we want to create our own list, we should try and give implementation to as many of that as possible. Now I tell you now, we have not done in this example. Some of the items that they can be done as assignments, some of them can be even done as exam questions, but only time will tell. So we provide in the folder all the code that's required. Codes used for slides is the folder name, it's under resources, and it's in study unit 3. We explain now that code line by line. But if you do not understand the big picture, then you have a problem. So first of all, we are starting with the class myArrayList. We take you back, let's just move me out of the way. We take you back to the driver program. The driver program used the class myArrayList to create a new array for him to be able to replace the built-in array of Java. So let's look at the first 12 lines. The subsequent slides will work through the array class in detail. If you wonder how long this will take you, there are 90 lines of code, so this is roughly 1/10 of the code. But we are going to take a break to limit the length of the video before we delve into the code. So we first start with the myArrayList class, and we take it from top to bottom, line by line. It is extremely important that you understand the detail. The aim is not only to make a generic array, but the aim is to make a generic array. So this is your time now to understand all the detail of the array class which we create, but also of arrays. So let's start. The first thing you have to notice is that in our array class we receive a parameter in the class name. Can you remember this from last semester? It means that the driver class will send us a parameter indicating the name of the class we have to use. Here at the bottom you will see that the test class, the driver class, in our case sends us a geometric object, but it can be anyone. This is the idea of writing a program that will be used by other programmers. In your assignment, you will create another test class, similar to this one here, with shapes, but you will use cell phone users of assignment 1 to do that class. So that's the first thing to notice. The other thing to notice is that Java permits us not to make an array of the type E or the generic type. And just one thing on the side, what this textbook uses E for, many other textbooks uses a T. You can make any variable name for that type. Most textbooks, actually, I have seen uses a capital T for type. This textbook uses a capital E because they want to, and we decided to follow suit. But you can use whatever variable you want to. Okay, so you know now the heading, you know the idea that we create an array of objects. Why 100? Because we wanted to. The textbook's version, that use something totally different. They extend the array all the time, but we are not going to go into that much detail. Just to remember that you can, it's a decision you have to take how large this array can be. You can also make it as one of the constructors to create the array of a specific length. So this is really the simple version. Just make an array of 100. Now, I said Java does not allow an array of data type E or generic type, but we are assigning it to the variable data, which is actually a reference to an array of E, but we are not allowed to create objects of that, so we are creating objects of the object type in Java. This is fairly standard. You only need to do this once and understand it once. So here comes it again. We are not able to create new objects of the type E in an array. Java does not permit that. So the workaround is to create objects of the object type and assign to a variable which we declare as if it's an array of E. It's just a workaround around something that Java does not permit. We also have a size variable. That size variable indicates the current size of the array. It tells us how many entries are currently stored in that array. Carefully look at this code. It is standard. It's going to stay like that. Now we are going to add methods to the class for manipulation of the array. Here's the add method. Remember I said it's now time to really understand arrays as well. An array is a data structure. Our array is numbered 0 to 99. An array has an index, but we decided that we have a different variable size. Size indicates how many items are stored. Now, if there's a one item in the array, it is stored at position 0. If there are two items in the array, it is stored at position 0 and position 1. We want to check if somebody adds something to the array, that the index parameter is smaller than size, because we want to make sure that we do not have open positions in the array. If we have two items in the array and we permit the user to add something here at position number 3, we have an opening in the array, and that we do not want. Okay, so let's look at the code. The code throws an exception, but exception handling is not part of this module, but it was done before, so we are not going to talk about it. You can just have a look at it. If the index is smaller than 0, why is that a problem? We don't want the user to send us an index of -1. -1 is a valid integer, so that user is able to send us an index of -1, so we first check. And we don't want the index to be larger than size, because then we are going to create openings in our array. So the method add receives an index and an object to store in that index. How are we going to do it? You understand now that if just check if it's a valid index, And if you look at the code from line 18, we are actually moving from the back end of the array, and we are shifting up all the elements. Let's draw a diagram of this. Let's do a better array here. If we have an array, small one, remember there are 99 positions that can be filled, but let's say position 0, 1, 2, 3 has been filled. Let's say 4, 5 and 6 has also been filled. Remember there it continues. So I have numbers, integers in it. So my user is using it with integers. So let's choose random integers to store in the array. And there are now many open positions because we have until 99. What is size at the moment? I'm going to change my 7 here because it will be confusing. Let's make that another 1. What is size? Size is the variable that contains the number of elements. How many elements are here? Size will be equal to 7. Okay, so what is this for doing? It is starting at position 6, do you agree? And it continues until index. What is index? Sorry for that. What is index? Index comes from there. Index is the item where the user wants to enter the item. So let's say the user said at position 2 a 4. So what should happen? At position 4, we should make space for that 4. So what we are doing, we are shifting everything up. We are working from the back of the array, from the rear of the array, and we are indeed making space for that new 4. Carefully look what's happening here. Data I plus 1 gets the value of data I, but it starts at size minus 1, so it will start at 6. So data I plus 1, data 7 there, will get the value of that one. And the next iteration of the 4, data I decrement, so I is now 5, so data I plus 1 will get the value of that one. And so it continues. We are shifting it until we reach index. So that 5 will become a 1, that 1 will become a 3, and until we are larger or equal to index. So we will stop when we are at position 2, and that position plus 1 is stored there. Okay, so now we have two 3s next to one another, but in line 21, we will assign to that position the number of 4. Why? Because that was our parameter. More important is how I have done this. I drew a picture, I gave my arrays value, and I've written down what the computer program does by reading the code. I think you need to rewind this, grab a pen and paper, and see if you can draw your own version by carefully looking where the 4 starts and what is done in the 4. Okay, I need to do one more thing. I need to increment my size. Why? Because I have one more element in my array now. do not continue with the video if you do not understand that. Rather reverse, rewind, and see if you can follow this. Why is this so important? Because we are going to expect you to write a new manipulation method for this array. Remember, there's a list. We do not give implementation of all those items, and we will find new ones to ask you. And this is a good example of one of the manipulation methods. Let's move on to other manipulation methods. The first one we are looking at is the contains method. Now, it's always very important to first understand what is done. What is the purpose of the method? This method contains receive an object, and it tests if that object is in the array. How does it do it? It walks through that array and it does it with the equals method. Now, it could have worked, of course, with an E there as well. It need not be an object. That array, many of these methods can handle an E because of how we specified the data field of the array. So it will, the nice word is traverse. Traverse. Traverse means visit every position in the array. So you traverse the array and compare each element of the array. Remember, the element is identified with data I to the parameter. And if it is true, you return true. So actually contains look for the first element. And if you have reached the end of the for, you know that element is not in the list, and then you can return false. So you traverse the list, you compare each element with the parameter E. If you find it, so if the equals is true, you return a true. But there is a catch. Where is the equals method that's being used? And what does it do? The first answer, it is in the object class. The second answer, it compares addresses, not values. It simply checks whether that specific object with that specific address has been added to the array or not. Except if you have overridden the equals method. If you have overridden the equals method in the class, which class? The class we use as E. In this case, in the geometric object class, or a subclass thereof. And yes, we did. We overridden the equals method to check arrays according to their radius. So this equals is one of those polymorphic methods that will be checked in the class that's using this class to understand which equals to be done. So let's say this again. If you do not override the equals method in the subclass, the equals method in line 28 will be the equals method in the object class. That method compares the addresses of the two objects. Remember, the name of the object is a separate variable containing the address of the first instance field, and those addresses will be compared. But if you override the equals method, you can change this, and we did so in the circle class. We changed the equal method to compare two circles according to their radius values. Okay, let's move on to the get method. The get method just returns the value at a specific index. And look at the return type. Now it's an E. So once again, we check the validity of that index. We make sure it's not out of bounds. When will it be out of bounds? When it's smaller than 0 or larger or equal to size. Why or equal? If our size is 7, there are 7 elements in the array, and they are stored from position 0 to 6. And therefore, if the index is equal to 7, it is actually out of bounds. It's in an empty part of the array. And it simply returns the data at that index. If you need to rewind listen again, we are helping you to solve all your array problems from last semesters. Let's take a break before we continue with line 39. Now we move to one of the more difficult methods, remove. Once again, you need to understand what is done by the method. And the easiest way to understand what exactly the method does is to look at the signature of the method, in this case line 29. This method receives an index and it returns a variable or object of type E. So I think it's going to return an object currently stored at position index and remove it. This is a lot of work. Let's see if you can understand it. Once again, draw yourself a diagram. I think that's the only way to understand. So let's draw ourselves again our array. We know it has a few filled positions. Position 0, 1, 2, 3. And this means that, let's go for numbers again, 7 and 8. Let's size is currently equal to, you tell me, 4. Okay, so, and let's say the user of the program called it with a 10. First of all, the same code over and over again. If index is larger than size, 10 is larger than size, it will be an error. So let's quickly go back to the user. No, you can't use a 10, use a 2. So at position 2, the user wants to remove. The question is, what should happen with the rest of the array? Can we leave an open space there? No, our array is better than that. Our array fills up all the gaps. So we have to think what we should do. And I think best is to fill up that position until the end of the array. I'm going to extend our array a little bit so that you better understand. Let's load a few more there and make the size 6. Don't hesitate to do that when you are trying to understand and you see your own example is not good enough. You just make a better example. So if I want to remove that one, what should I do? I should fill the gap. And I should then, if I move that 7 to that position, I should also move the 2 and I should move the 1. I should indeed move all the values from the end or up to the end, one position back. Let's look at the code. Line 43. I create a variable of type E. I call it E just for the fun of it. I could call it item to be deleted, but that would be too long to type. And I store the data of index. What is index? Index is the variable, let's say 2. So unfortunately my example has a 2 there at position 2, which makes it a bit confusing. So let's make it a 21. So I'm going to store that 21, which is at position 2, into E. What will happen with it? It will be returned. So this is what we predicted this method to do. It returns the value stored at the specific index. Okay, so that we understand. Now we shift the data to the left. Shift to the left means that side, because we want to close the gap. So from where do we start? We start at position index. Where do we stop? Very important, smaller than, not smaller than equal, smaller to size minus 1, because the last position is already size minus 1. If size is 6, our last position is 5, because our array starts at 0. So smaller than size minus 1 will stop at the right place. Okay. So you take, what are we doing? We are replacing the current position with its next door neighbor. So we can stop actually there. So we replace the 21 by a 7. We move on. We replace the 2, the 7 by that 7, we replace by the 2, and we replace the 2 by the 1. Can you see why we stop here at smaller than? Otherwise, j plus 1 would have been out of bounds. And what else should we do? We should decrement size. I want you to carefully think how we have done this. Not in terms of exactly what we have done, but how we decided. We drew a picture, and then we decided what must be done, and then we did the Java. So we drew a picture, figured out on the picture how we should go about, and then we've written the Java. Finally, a ToString and a mutator on the size. A ToString and a mutator on the size. The ToString, you can do whatever you want, but the most important is you return the result here. You do not write on the screen. Why don't you write on the screen? Because you don't know what the programmer wants to do with the code. You don't know if the programmer perhaps wants to create a GUI. If the programmer wanted a GUI and you put a system out print line here, then the programmer won't appreciate you, because he wants to write a nice program, and every time he calls ToString, there's a line of output at a random place on the screen. So ToString typically returns a string. Okay, and a mutator on size. Let's take a break, because we start with the most important part next, the sorting. We have reached now the most important part of the code. And this is the part I every time refer to as, we'll see later. Now it's later. If you don't understand all the code up to now, re-watch the videos, because it's going to get a bit tougher now. And if you still have problems, ask in the chat room. We want to sort the array now. But according to what? How are we going to sort it? Are we going to sort it according to the area of the shapes? No, what am I talking about shapes now? Some programmer will use it with shapes, others will use it with cell phones. How on earth are we going to sort an array when we don't know what's in the array? That is the big question. So first of all, you have to understand the problem we are solving. We want to compare the elements in the array for more than equal. You know that we can override the equal method. But we want to do more. We want to compare for bigger, smaller, equal, also alphabetically, so that we can sort this array. This is where the compareTo method comes in. You have studied the compareTo in chapter 13.6 last semester, but here is a good implementation of compareTo. Now there are many ways to implement this, and the one here we believe is the simplest and the easiest to understand. So what are the big picture? What's the big picture? We are using the compareTo method in a polymorphic way to be able to compare objects of the type E in our array class. So what's the answer to the question? How are we comparing the elements? You know what's the answer? We don't know, the class knows. Here we call compareTo, but we don't worry what compareTo does. We only worry about the result of the compareTo. If compareTo gives us a number bigger than 1 or equal to 1, it means that the calling object is larger than the parameter object. If the compareTo method returns a value of -1 or smaller, then it means that the parameter object is in fact larger than the calling object. If it's a number equal to 0, it means the two are equal. The parameter object is equal to the calling object. So how do we compare it? We don't know. We are only interested in the return values of compareTo. The detail should be provided by the class who wants to use our array. So let's look at the sort. This is bubble sort. I hate bubble sort, but you know bubble sort. And this is for some of the last times you will see bubble sort. But why are we using bubble sort? Is to minimize the complexity of what we are doing. A double for loop is swapping of variables. To swap variables you need the temporary variable hold. Note the type of that variable is E. And the crux, the only line here that must tickle you, is line 73. We compare data J with its neighbor. That's part of bubble sort. By the way, if you struggle with bubble sort and this code, go and find a YouTube video for bubble sort in Java, and then somebody will explain it to you. But that's also a part of the course later. But I'm sure you have done sorting last semester. We need to activate the compareTo method in the calling class. That's a mouthful. We want to ensure that the compareTo method in the circle class is used if this is a circle. So how do we achieve that? We cast the calling object to a comparable. Now there's a catch. You have done it last semester. You need this bracket and that bracket to indicate preference of operation. We first do the casting before we access the method. If you don't have that bracket, you get a very weird error, and I did not know that the error I couldn't connect to this problem. So have a look. There's a bracket and there's a bracket. We do the casting to comparable before we access the method. If you don't have that brackets, you get an error. So just remember to add those brackets. So you first cast the variable to a comparable, and then you can call it compareTo. So this is called this is called the calling object, and this is called the parameter object. So we've talked about compareTo. compareTo, we don't know how the circle class or the geometric object class is going to handle it. We'll see that later. But we worry about what it returns. So if the first one is bigger than the second one, if the calling object is larger than the parameter object, compareTo should return a number larger than 0. And this is what happens there. If we did not use comparable, we wanted to write here data j is larger than data j plus 1. But this is not allowed. We need to use the compareTo because we are working with generics. But these two statements are actually achieving the same, although the top one, handwritten one, won't work. But logically, this is what we are doing. We say if data j is larger than data j plus 1, which is typical in bubble sort. Rewind if you need to listen to the story again. Okay, now we have done the sort. We have worked through the entire class. And now we ask the question, if a programmer wants to use our class, what should he do? There's only a few steps of what should be done. And you should do the same steps in your assignment, because you have to get all of this working for the cell user class. Okay, let's have a look. The first thing is our superclass geometric object. Remember, I've moved now from my super programming role to my normal programmer. I'm now a normal programmer I heard that there's this new class in Java that makes arrays easier, and I'm going to use it. So what I want to do is, first of all, I need to change the heading of my superclass to have this part here. It must implement comparable geometric object. But remember, geometric object is an abstract class. So by saying it implements comparable, it just adds more methods to the list of abstract methods. And comparable, you know from last semester, only has one method called compareTo. Now with this parameter here, I just tell compareTo, the comparable class, how to do the compareTo, or with what data to do the compareTo. Okay? The subclass, so circle, must implement comparable. But it's a bit tough, and we will look at it right now. It's very important to know that the parameter type in that subclass must be the superclass's name. It comes from sending the superclass name there. We will look at the entire method now. This is the compareTo method in the circle. So first of all, understand that its parameter must be an object of the superclass, or a reference, because you know it's not an object, there's not a new involved. So first of all, before I can start comparing, I have to determine that I'm comparing, as the idiom says, apples with apples, or in this case, circles with circles. So I'm first checking to see whether G is a circle. How do I do this? I use the method getClass. So I compare this getClass, that would be the calling object, and the getClass of the parameter object. Now we spoke about calling objects and parameter objects, but let's go back a little bit. If you look at this statement, this part is the calling object, and because it calls the method, and that part is the parameter object. Go back to the videos of study unit 1 if you do not understand it. So the calling object is always referred to as this variable. So here the class of this of the calling variable is compared with the class of the parameter variable. Why? How do I know it? There's a G and there's a G. If it's the same, I can continue. If it's the same, I'm casting, it's actually a downcast here if you want to be technical, this geometric object to a circle. And now I can use it as a circle. how do I compare circles with one another? Previously we used the radius, but now we use the area. There's a reason for it, because a rectangle also has an area. Okay, so I get the area of circle C, but what circle C? Circle C comes from actually the parameter object. So I'm comparing the area of the calling object with the area of the parameter object. If they are equal, I can return a 0. Why 0? I'm complying to the rules of compareTo. So if the area of the calling object is smaller than the area of the parameter object, I'm going to return a -1. Why -1? Once again, I'm complying to the rules of compareTo, and else would mean it's larger than, and therefore a 1. Now this else here is interesting, but not so important for you to understand. It is the else of this if. That if tested to see if both the calling object and the parameter object have the same class. What if it's not? Then I'm comparing apples with pears, or perhaps circles with rectangles. So I don't want to raise an error. I could have. That would be one thing. But then I sort of limit my use of polymorphism a lot. A trick is to get the name of the class, so this, let's say the calling object was a circle, and compare it with the name of the parameter, let's say it was a rectangle. Remember, that is now a string. Get name returns a string. And if I compare it, what do you think with compareTo in the string class does? Because I actually call the compareTo in the string class. You guessed right. The string class is compareTo, compare it in terms of alphabetical order. So why would I do this? It's just to create some answer for this method. And what's more, if I want to sort it, the items in the array, it will keep all the objects of a specific class adjacent to one another. Because if two of them does not have the same class, it will swap them around, and all the ones of a specific class will end up together. But the red line here is of major importance. It says that if you want to use the myArrayList, you must include an implementation of compareTo, not any one of the superclass. Because why the superclass? Because it's the superclass that implemented comparable, and in the driver it's the superclass we give there to myArrayList to say this ArrayList is going to be full of the superclass. So look at our test program. We've done this before. You just add objects at a specific position. We start by creating an object of our new ArrayList, but we do not only create an object, we have to tell it of which type. So we send our superclass there. And then we create a lot of circles, a few rectangles, and we add it to the list. Then we sort it. Now in the rectangle class, you know that there's also a compareTo method. And you guessed it, it also compares the areas. But, what will be the output of this method? Will the output of the program? Will the areas be really mixed between the rectangles? Let's say the area of that circle, and I'm not computing it. I'm not quick enough with my pi. Let's say this one is 19, this one is 16, this one is, let's say, 3.14, this one is 31. I think those guesstimates might not be that bad. This one is, the first one is 20, the second one is 6, that one is 9, that one is 16. Will my final list be a mix of these? Will my final list be, what's the smallest? 3.14, then the 6, then the 9, then a 16, then a 16. No, this is not what my output will be. Why? Because I can't compare apples to pears. I can't compare circles to rectangles. My compareTo checks first before considering the area. My compareTo compares the name of the classes. And with that trick in the else, all my rectangles will move to the latter part of my output, simply because rectangle, the word, is later in the alphabet than circle, the term. So my output, and you have to go and run and test it to see my output, my correct output would be first my circle sorted, so my output will be something like this, which is this next one, 16, 19, and then 31, and then all my rectangles will follow also in order of area. So this would be the correct output according to the code of the areas. You can't compare apples to pears, therefore that else in the compareTo will shift all the rectangles later on. That's the end of my story for now. Once again, this is, I think, almost the most complex thing to understand initially in the module, but it should not be new to you because you have done it all in the previous semester. Go and play with the code so that you understand it. And good luck with your assignment. I can just tell you, when I did your assignment, it took less than 15 minutes to make the few changes required for this. Carefully look at the instruction of your assignment. Welcome to the second session on Study Unit 3 on generic linked lists. We are now going to do an example. This example will help you a lot in the exam. I'm going to explain all the detail required as if you have no programming experience. So if you find that my level is perhaps a bit lower than your knowledge, you can read the slides and only listen to the sections that you are not 100% clear. For those of you who always battled with programming, now's the time to fix the problem. Before we start, we are going to update our myArrayList class a little bit. You will remember that we said the array can only be 100 elements, and we hard-coded that. We had it in brackets when we created the object array. Have a look at this code. This is a little bit of a more elegant solution to that problem. You will see line 6, we define a variable called max elements, and we set that equal to 100. And then in line 9, we use our new variable max element. So whenever we want to use now the number 100, we can simply use the number of elements or the max elements variable. Another improvement is we need to write a manipulation method to clear the array. Yes, it was one of the methods on that list of manipulation methods required for a list. Now, can you think how we can clear this array? What would you do? If I tell you it only contains one line of code, Will you believe me? Can you imagine what that line of code is? Were you right? If we set the size to 0, all the methods will, using this array, will use size for 0 and the array will be empty. Actually, the old values are still there, but they will be overridden by new data when we add new data in the array. Think about this clearly. If you still can't understand, play with it. Write a test program and set size to 0 with a clear method and see what happens. In the third class example, or the third session, the second class example, it is crucial, so then you will gain more experience of the clear method. The third and final thing before we start off is the integer wrapper class. In Java, you get two types of classes. You get the primitive types. You know them, int, double, character. Those are all spelled with small caps. But then you can also create your own objects as defined of classes, and they are called string. That's a built-in one which you use often. You created one circle. You created one prepaid user, and so you can create many more. But objects are not primitive types. They have a major difference. And the difference is that red sentence on this slide. The name of the object is a separate variable containing the address of the first field of the object. So the name is not really a value. It is a value, but it's a value of an address. And you know that we need to create an array of objects with a capital letter O, the built-in class of Java, when we create our array in the custom class. And we cannot convert primitive data variables to objects. So therefore we can not use this class, this custom array class, with primitive types. Luckily for us, Java created a wrapper class for primitive integer. Now wrapper, I want you to think about your favorite chocolate bar. It has a wrapper, and that the little plastic printed part with a label on it, that is a wrapper. What do you get when you take off the chocolate's wrapper? Aha, the chocolate. What do you get when you take off the integer's wrapper? Aha, a primitive integer. So, if you consider that code, the primitive type would be int a equals 4. This line here, that is primitive type integer. Here we use the wrapper class. We say, create an object of the class integer, make a new one, that means call the constructor, and assign the value 5 to the instance variable of the class integer. The instance variable of the class integer's name is value. Okay, and to test if you really understand, let's look at the memory. The blue diagram is the primitive type. For every primitive variable in memory, you have three things. One, there's a name, in this case a, then there's a contents or a value, and it is always stored at a specific position or memory address. Well, what number is A2003? That is a hexadecimal number. A hexadecimal number contains, the addresses in memory is typically a hexadecimal number. Okay, so now you understand the blue diagram. So every primitive type has a name, a content, and an address. So at position A2003, there is a name and a content. If you look now at the orange, first look at that orange sentence there at bullet 2. The name of the object is a separate variable containing the address of the first field. Let's have a look here. The name of the object, here it is a separate variable, almost like the primitive one. Its name is the name of the object. It is a separate variable, so it has its own address, but the value is the address of the starting position of the first instance field. I told you the instance field of an integer is called value. So and value is stored at 4823, and therefore this separate variable with the same name as the object's contents is that address of the first variable. That is rather hard to understand. Have a look, stare a little bit, pause, re-listen. Do not go on. Do not continue to the next slide before you understand that. If you need to, ask in the chat room. Okay, once you understand that, let's try to apply the same thing to an array. Stare a little bit here. This is now an array of integers with a capital I. But the same rule applies for the array itself. Let's have a look what's going on here. This is the orange. It's a depiction of a object of the myArrayList class. You know that the myArrayList class has a size, which is a primitive type, therefore it can have a straight value, and it has a data element, which is an object of array, an array of objects. What does that really mean? It means it's an array of addresses, and the address is stored in that array. So these addresses in the dark orange are actually the addresses which are stored in the data elements of that array. These lighter ones are the addresses of the separate variables. So data 0 is a separate variable at position E002, and it contains the address F245B, and if you go to that address F245B, you will find an integer value. And that address would be the starting point of the value field of the integer. Let's take the next one. An array has a number of items. Each item is stored in its separate memory position. Each of those memory positions have indeed its own address. You will see they are adjacent. That's very important to understand. You will see that I make a skip of 2 bytes every time. If I take that hexadecimal number E002, I add 2, I get E004. If I add 2, I get E006. Add another 2, 8. Now 10 is represented in hexadecimal numbers by A. So that A is actually 10. Add 2 to 10, then you get A, B, C. Add 2, C, D, E. Sorry, that must be an E. I will fix this slide. Okay, so now you know where those numbers come from. They are adjacent numbers on the in the array. Each of them has a name. Those are the square brackets with the index, and each has a content. And that content is the address of an integer object. This is frustrating and hard to understand, but be patient with yourself. If you are now totally lost, again look at the previous slide. But we cannot draw that diagram every time in that fashion. So we are going to simplify it. We are going to simplify it by simply drawing a single array with those values in blue already in the array and with index numbers. Okay, I think it's important that you realize that the actual values in memory are not adjacent to one another. The elements of the array is adjacent to one another, but they can point to any, they can have any address in memory that they can point to. So have a look at the differences in the order of the blue and the order of the orange. You will see that I've ordered this list of blue items from smallest to largest hexadecimal numbers. So relax a bit, have a look at this, and do not continue if you do not have this, if you do not understand this, because now we are going to start with our real example. Welcome back. Our first complete example of a question that is similar to the questions you can expect in the examination. Let's read this carefully. This is written in the same style as the examination question. Design is the first word you have to see, and implement a filter method for the myArray class. This is the unique part. This is the name of the method is question specific. Now you should read what the filter method must do. The method should receive two generic objects as parameters. Are your mind already solving this? Two generic objects as parameters, and remove all the items from the calling list that is smaller than the first parameter and larger than the second parameter. Do you know now why it is called filter? Filter is when we take something out of something else. The original array should be updated, changed. It filters the array according to parameters. What should you do? You should first of all follow the three-step method for designing a method. Then you have to develop the Java code. And then you have to test it, you've guessed it, with the integer wrapper class. So this example will not only teach you the three-step method, it will also show you exactly how to apply it. There's a lot of marks for this question. Such a question almost counts 20 marks in the examination. But you cannot go to the next slide if you do not have a picture in your mind what filter does. It receives two parameters, and your list is filtered to only contain items within these two parameters. Now for the methodology, three-step methodology. Step 1 has 3 small steps. Write down the method call in the test program with variable names. This is how you would call this method. List1.filter, because that's a method name, and 2 variables, a low and a high. You can call them anything. I call them low and high because I think it suits the question. And the list1 is a myArray list, and the low and the high depends on the class. Therefore, it is of type E. Now, if I draw the diagram, I have a myArray list here in orange, and I have the 2 parameter list variables here in blue. What did you learn in the previous video? This is not the real thing, this is not what you see. The real one has a lot of small blocks and addresses, but let's stick to the simplified version. So if this is your input, this is your output. Now is the time to really understand the method. can you see what was done? The array was filtered according to the high and the low value of 3 and 5. So what did I actually do? I compared each one of the elements in data with those two values, and I decided whether it should go in the final array or it should remain in the array, depending on how you look at it. So can you see that all the values here, which are lower than the low value or higher than the high value, has been filtered out. You now understand the name of the record? The values has been filtered out. So you can have a look here. Is this 6 within the range of 3 to 5? No. So it does not appear in the final array. Is the 5 in that range? Yes. So it's there. Now you know that the filter is inclusive of all the numbers, including the filter is legal. Is the 3 within those values? Yes, it's there. The 4 within those values? Yes, there it is. Is this 2 between 3 and 5? No, that's why it's not there. Is the 5 between 3 and 5? Yes, there it goes. And is the 1 between 3 and 5? No. So we've drawn the diagram. Now for the overall plan. Think, how can we write in words what our mind just did? Let's have a look. This one is tricky. You have two options. You can say, you can traverse the calling array, that's now that orange, check each element and call remove if the element is invalid. So you can, if we play computer, traverse means step through the array. So you can look at 6. Is it valid? Is it between 3 and 5? No. So let's call remove, because our class has a remove method. And just remove it. That will work. So, and then we continue to the 5. Is the 5 valid? Yes. So we won't call remove. Is the 3 valid? Nope. And then until we get to that 2, it's not a valid value. So we just simply call remove again. That seems like a logical idea, but there's indeed another idea as well. So let's just clean up a bit here. The second idea is we can create a new array and walk through this and do the check and only add the valid values to a new array. And then when we are done, we replace the original array with a new array. So let's see what our idea is then. We again traverse the original array. 6, and then is it between 3 and 5? No, so we don't add it. Continue. Is the 5 between 3 and 5? Yes, so let's add it to the new array. Is the 3 valid? Yes, let's add it. Is the 4 valid? Yes, let's add it. Is the 2 valid? Nope. Not going to add that. The 5 is valid, the 1 is not valid. So in the first option we focus on removal, and the second option we focus on adding new values. How do we decide? The answer is in study unit 2. Now for something brand new. Now we are going to use our knowledge of asymptotic analysis to figure out which one is best. Follow the argument. Number 1 here goes with option 1 and number 2 is option 2. Now we are going to talk about the asymptotic analysis of each of these methods or options. The first option removes. Remember that remove, and if you have to go back to the class, you have to pause now, go back to the class, check the code, and come back. Did you see that remove shifts on the elements so that there's not a gap in the array? So in the worst case, when I remove the very first item, all the elements are shifted. which is an order n operation. So I say n elements can be shifted, so that can be order n. Okay, but how many times should I do it? In the worst case scenario, I have to remove all the elements in the array. Let's say all of these elements were outside that range. That would have meant that I remove all the elements. And that could have been nasty if I called remove n times. So I can call remove n times. Remove is order n, and n times order n, remember those theorems in the previous study guide, will leave you with order n squared. So the worst case, option 1, will leave me with order n squared. That's not good. Let's think about option 2. Option 2, by adding items in an array. If I call the add method, I can be in trouble. But if I add it manually, one by one, without calling the add method, I can traverse the data and I can walk once through it and every time do a check. And depending on the result of the check, that 6 the check is false, the 5 the check is true. Every time simply add an item. I can, with one traversal of the list, be done. Then I have a new list. But there's something else I have to do. I have to replace the original list with this new temporary list. But there's a sentence that says the name of an object is a variable containing the address of the starting point. That means if I say temp, which is a name, is address, I copy, in fact, the entire array. Then temp refers to that array. That's order 1. So option 2 is an order n operation, because I can do it with only going through the array once. We saw that option 1 is order n squared. Now which one is best, quickest, most effective? Order n squared or order n? You've guessed it, order n. So therefore we are doing option 2. So we can continue with selecting option 2 as our overall plan. So we create a new array and load only valid elements and then replace the original array. If it helps you, you can view this in terms of input, processing and output. Our input is an array, which is the calling array with 2 parameters, and then our processing is to create that new array, and our output is the new array, but we have to remember that it's the calling array that needs to be replaced. If you don't know why, go back to the assignment. The assignment said we have to update the calling array. We are going to take a break so that you can re-watch this video if you do not understand all the detail. Make sure you understand this slide and the 2 options and the reason for choosing the second option before you continue with the next part. Step 2 is all about writing small Java steps or English steps that will become Java steps later. And look at the corner of the screen. There's your diagram. So once again, if you don't understand everything on that diagram, rather go back. Now step 2, we also divide in sub-steps. The first one is identify data structures in terms of calling and parameter and return structures. So I want you to identify those 2 there as parameters, and this big block here as the calling array. Is this the return array? No, not in this case, because the question said we have to update the returning array. This method does not return anything. And that is why this is a very important step. You have to figure out during this step, what is the calling array on the diagram? Are there any parameters? And what do you return? Or are you only changing the instance fields of the calling object? How do you know what are the parameters? That's kind of easy. You ask yourself, what is necessary to do the job? I cannot send somebody to go and filter the array for me, but I don't give them a high and low value. Do you agree? So if I ask somebody to filter the array, look at this line, I have to give them a low and a high value. Now this line comes from the test program, and you will see two wrapper integer variables are used there in brackets. So I do two things. I write down the call from the test method, but I also write down the heading in the data class, in the myArrayList, the class which contains that array. That will be the heading. Now we are going to write the programming steps in Java. Like Java, but we are not going to write it in Java itself. Now I want you to pause a bit and think first, what are the steps the method must do? We know now what's the heading, we know now what the parameter names are, we know the variable names of the calling object. Now the steps. Pause and write down the steps. Welcome back. Have a look at mine. Is it similar to yours? You will get to know the lingo. The most important thing is to have the idea right. The first step is to create a new array so that we can store the correct or the valid values in there. And then the next step is to traverse. Remember we learned that word. Traverse the calling array with counter I. Now your step need not be exactly like mine, just the general idea. And compare each value to the parameter. Now you can write its if to show that you understand what. If data I is larger than low and smaller than high, add it to the new list. Now what you should understand is that you need a new counter here. I traverses that list, but J does not increment every time I increment. J only increments for valid values. So when I have a valid value, I add it to the array and I increment it. Obviously, J must start somewhere as 0. Do you agree? And if I through that entire loop, that's a loop there, that part is a loop. If I'm through the entire loop, I must replace my calling variable's data by 10. And I have to set the size. Now I'm talking about that size. But where do I get the size? Yes, you are right. It's the value of J, because J would have been 0, then 1, then 2, then 3. And every time I would have incremented J. And remember, J is once incremented after it was used for the last time. So J is in fact at the moment equal to 4. Carefully consider that. The first time J is equal to 0. Then I store it and I increment J. Store it, increment J. J becoming 2. Store it, increment J. Store it, increment J. So I will store at position 3, but finally J would be equal to 4 because I have incremented it after I used it to store the data. Have a look at your steps and of mine. And if you did not write the steps, you know what I mean now when I say pause and do it yourself. Because it is so much better if you try it first yourself and then check your idea against mine. Step 3 is to write down the special cases. The special cases is what can go wrong. What can go wrong? And we will pause here. Okay, let's have a look at the special cases. The question is what can go wrong. Now when it's your first time, it's very hard to get this from your own creative thinking. But if you have seen a number of examples, you will find it's the easy part. What can go wrong? The first thing that can sort of go wrong is that calling list, this list here, can be empty. You agree? That's something that can go wrong. And the second thing that go terribly wrong is if those two values are reversed. If you have a 5 and a 3 there. Yes, because then nothing is in a range, because there's not a valid range. So those are the two things in this example that can go wrong. You can't memorize this. You have to know this for every example. Every example have their own special cases. So what's our proposed solution? So for the first special case is the calling array can be empty. Our solution, how do we check it? We simply check if size is 0 and then we just return. The second item there, if we check if low is higher than high, then we know we have a problem. Then we can either raise the exception or just return. Let's decide just to return to make it simple. Now let's just move me out of the place here. Now we are ready to write the Java code. The best way is to get everything you've done together. We've drawn the diagram, we've figured out all the headings of the method and how we will call it. We've written the code actually very close to Java but not quite Java, and we made a list of all the special cases. And now you can, and I ask you to please do this, pause and write the program. See how close you can come, but you cannot now use your own ideas. You have to implement this. You have to write a Java program from that. See if you can do that, but pause and do it, and then hit play again when you are done. Okay, let's take it step by step and see if you can, how you've done. We are first going to look at the heading, only the heading. We've thought about this already, so we know our heading on line 59 is public void. Why void? We return nothing. We change the calling array, so there's nothing to return. We need two things to do our work, a low and a high. What's the data type? Yes, you've guessed it. E. Why? Because we don't know what objects they are. They are generic objects, and we are using the generic type identifier label E. I'm one of those programmers that prefer to list all my variables at the beginning of code and not during the code. So I need a J, which is going to be my counter in my new list, and I need a new list. Now, why did I do it like I've done? You can simply go here and see how you've created the original array for in the class. This is the constructor of the class myArrayList. Now, remember, if you don't know, that this line 59 is down here, 59, it's the same program. We are actually busy writing a method for the same class. So you can simply copy that code. Oh, I'm not going to explain it now again. I explained it in the video of Study Unit 3, the session 1 videos. I think it was in part 1 or 2, you can go back and find that. Okay, so here you can now start to tick. That is, create a new array called temp. Yes, I've done that, to be traversed by counter j. So there's two things to get here. Is to see how easy the Java becomes when you really know what you are trying to do. That Java, it's like translating our English into Java. We write smart English, we know. We write English that's easily translatable. But the Java translation is actually the easier part. It's how to get to these steps that's the challenging part. And the more time you spend in writing steps, the easier it is. Okay, so if you feel you want to do better than you have done, pause again and continue with the program. We are going to continue with these steps here on the next slide. Okay, so we are first of all going to look at the special cases. I always put it in red on this list here on the right hand side, what the code is all about. So the special cases, I have to check if size is 0 and return. Get size returns the instance variable sizes value. That was easy enough. And now my second one, check if low is larger than high and return. Now you've seen this compareTo thing in the previous study unit or session of study unit 3. You have to go back if you do not understand. But before you go back, here's again the explanation. So perhaps along with this explanation and the previous one you can understand compareTo. I have to tell you, this is the final time I explain compareTo. After that, now I just use it. Okay, here it comes. Low is of generic type E. High is of generic type E. It can be a circle. It can be a prepaid user. It can be a rectangle. How do I compare two rectangles? How do I compare two prepaid users? The programmer of this code does not know. The programmer of this code does not know which objects will be loaded in E. So how do I compare it? The answer is simple. It's not my problem. Let circle tell me how to compare two circles. Let prepaid users tell me how to compare two. How do they tell me? They give an implementation for the method compareTo. From your homework you will know how to do this. And if you do not, go and study the proposed solution for the previous homework. But what is important is that a compareTo always uses the same way. It returns either a number larger than 0, a number smaller than 0, or a number equal to 0. When that number is larger than 0, it means that the calling object, this is the calling object because it calls the method, is larger than the parameter object. Can you see the high is a parameter, it's in brackets. When that return value is equal to 0, it means the calling value is equal to the parameter value, equal by value, not by address. It's not the same thing, its value is equal. And when it's smaller than 0, it means that this first calling object is indeed smaller than the parameter object. So we are going to use the class integer, the wrapper class, and guess what? That class already has a compareTo, which works according to these rules. Now, let me just clean away all my writing for the moment and focus your attention once more. There are 3 brackets. There's a bracket, there's a bracket, there's a bracket. If you don't do it exactly like that, Java gives you errors, and from that error message it's extremely difficult to understand where the error is. So get this right from the start. whenever you use a compareTo, start with those 3 brackets. Okay, most of you would need to pause now and re-listen to this part. Welcome back. You are now a pro on compareTo, and once you are a pro on compareTo, you will find that this code here, the general steps, and that code maps extremely easily, because the most difficult part is this compareTo. But there, and I've repeated it here, it's exactly that code, and you know you understand that code there, so you can just sit and stare at that compareTo until you understand it. But compareTos are easy now for you. So let's go through the logics again. Run with a for right through the list. We call that traverse. From 0 to smaller than size. Remember that array starts at 0. Then check every position data I. Compare it to the ranges you find in the parameter low and high. If it's in range, a valid value, then add it to position J of the new array. J, right there at the top, starts at 0, and J is incremented. J is incremented after we've used it. So at the end, J will be 1 more, or 1 more than the place we've stored the final time. But that says that J will actually be the right number. We've stored at position 3, and J ends at position 4. If you still don't understand that, write down all the iterations for yourself. And so temp is finished up to there. Now we have to replace the calling array. How do we do it? We simply say data equals temp. What's the value of temp? The name of an array is a separate variable containing the address of the first position. So I'm taking the address of the first position and I'm giving that to data. And I'm updating size as well. And that's the entire story. There's the entire program. Have a look at it. I'm going to take a break, and let's get back for the test program. Before we head to the test program, did you see how you used all your planning to create a program in Java? Did you also notice how easy it was because your planning was done well? Let's move on to the art of writing a test program. A test program. Remember, the assignment said right at the beginning, test the method thoroughly. That's something new. We have not done this in this module. The art of a test program says we have to test all the special cases, we have to test all the if statements, we have to give proper output statements, and we need to use proper coding. Nice coding techniques. So we have to, before we do it, because I will pause and you can do it yourself, we have to test the special cases. How will we do that? Yes, you're right. We are going to filter an empty array. Before we add data to that array, we are going to filter it. We are going to filter it with wrong values to test that special case number 2. We are going to, what are we going to do? We are going to empty array with wrong numbers, but we are going to have right numbers there as well, correct numbers, so that we can test it. Oh, I want clear output statements so that we can see what we are testing. So let's have a look. Now, what I always do when I test, when I create a test program. Let's put me there. I bring my test cases in and I bring my code in. Because if I have those two, I can make sure that I cover everything. So I create a new array and then I test it with the empty list. So that list is empty. Do you agree that list is empty? And now I filter it with two new parameter values. Yes, I could have said low equals new integer 3 and high equals new integer 5 on a separate line. But you can, it's kind of a shortcut to do it like that. All in the same brackets. The question is, can you see that line 7 or line 6 or line 7 actually calls the method? Every time I say test, I mean call the method. Can you see the method filter is called there? But what is in list? List is empty. So I'm actually testing at the moment that if. Okay? Now I add items to the list. How many? It doesn't matter how many. You just need to add enough so that you can properly test it. I just took the ones from the question. Okay? Now I'm going to test this if here, which is my second special case. So I'm going to test it with, can you see my heading? Test it with low, larger than high, low, larger than high, and I test it. I call my method, and I give output the list so that I can see what happened. What should happen? Nothing, because I just returned it. The original list must be returned. And now I test the proper one, where low is smaller than high. And I test it again with a 3 and a 5, but this time the 3 and the 5 is the right way. And I give output. Now, did we test? Yes, we did this, because there are numbers to be filtered out. We did that because of that if there, we did that. And we test all our special cases. Let's have a look at the output. So this line, there's the test with low smaller than high. Test this, the empty one. Let me just fix that. Test with low smaller and high, and so. Can you see what you've done? Can you see that you've succeeded in writing this program? Congratulations. This is very special. You've progressed towards. There's another example waiting for you. And then you are fully. But now you are almost fully. You've progressed towards understanding the manipulation of generic arrays. You know everything that's needed to know. The rest is just another example. But now you have to take a proper break, because the next example is rather challenging. So I think you should wait until another day before you take on that example. Welcome to the second class example and the final part of study unit 3. It won't work if you do this before understanding the first class example, because there's many things I'm not going to re-explain in this class example. If you feel you still have a problem with the second one, perhaps you can look through this one, and sometimes when you see a similar example, sometimes you get to understand everything all at once. This happens to a lot of students. They just sit and look through the video and then go back to the previous one. And in between, they understand things. Remember, the chat room is there for you. So you can ask questions. You can refer to videos, you can refer to times areas of videos. You can write to us that in this part of that video at that time period you do not understand. Okay, let's look at this one. This one is kind of the most difficult thing you would have to do. So I'm not going to explain anything about compareTos or the steps in the methodology. I'm just going to focus on the answer for this question. And the more you can do it on your own, the better. So I challenge you. Take time, pause the video from time to time, and first write your answer for the next slide before I give you the answer. Okay, let's go to the problem. It's a classic. Merging is a classic. Okay, let's read it. Design and implement a merge method. Merge method for the myArrayList class. The method should receive another object of this class. Major hint. Receive a major object of this class. What does that mean? Yes, it must receive another myArrayList as parameter and return. I tell you what must be returned. Return a new array resulting from merging the original array with the parameter array. The original array should not be updated. Not be updated. Okay? Do you know what merging is? In the exam, I will give you an example here of the numbers. Let's give you an example. If I have two lists, and my one list is that, and my other list is that. So that's list 1, list 2. Okay, you write down or help me. What's the merged list? That's a 13. First of all, assume both lists are sorted. So it's 2, 4, 7, and 8. That is sorted. 1, 3, 4, and 13. That is sorted. The merge, you guessed it, is 1, 2, 3, 4, 4, 7, 8, and 13. It's a list where the two are combined in a sorted fashion. But you will note that from now on. So now you know what does merging mean. It's a very often used procedure in all computing. You will learn about it in networks, you will learn about it in databases everywhere. There's merging going on. So what's the question? Write a merge method. The merge method should receive another object from this class and return a new array resulting from the merger of the original array and the parameter array. The original array should not be updated. Follow the 3-step method. Develop the Java code. You have to test it thoroughly. Now you know this thoroughly is not a light statement using the integer wrapper class. And assume that both bits are sorted, otherwise merging doesn't work. That's not a special case. We tell you can assume that, otherwise you waste time to do this. Okay, you can do this on your own, but you can look at mine, but if you quickly want to pause and draw your own, do so. Remember, whenever you see diagrams like this is a simplified version. In session 2, in part 1, I showed you the real version, but we are not drawing that every time. What's the first step? Write down the method calling the test program. And there it sits. You know, you can't understand the method if you can't do this. In the test program, you will say list 3, which is a new one, is list 1 dot merge, and then the parameter is list 2. If you need to, go back to the previous slide, read the question again, and continue reading that question, looking at this line until you know exactly why it is like that. Draw the diagram. How many lists are we drawing? If you do this in the exam, that's easy for me to mark. I just check whether you have the right number of lists. Do you understand why you have 3? So this one is that first one, the second one, and the result. Write the overall plan. What are we going to do? How will we explain to somebody what is the process our heads go through so that we can end up in Java code? Have a think about this. Put it forward. Do you have your own story now? What do you know the question? The question is really, if you should come and call somebody, your little nephew, brother, sister, daughter, son, and you ask them to merge two lists, and they tell you, but how do I do it? This is the answer. This is what we are looking for. We are looking for description for somebody that does not know it. Okay. How will you merge? More or less, you will start with a counter in each list, and then you will compare the two numbers at the counter, and you will take the smallest one and put it in the list. You will take the 8, compare it with the 6, and put the smallest one in the list. The one that you add to the list, you will increment that counter. Okay? And now you will compare the 12 to the 8. Put the smallest one in the list and increment the counter. We will compare the two numbers at the counters. Now I compare the 17 with the 12. Put the smallest one in the list, there's the 12 in the list, and increment that counter. Now I compare the 19 with the 17. Yes, you are right. The 17 goes to the list, and I increment the counter. Compare the 18 and the 19, or 2 in a row, 2 blue ones in a row. Go there and increment the counter. Compare the two values at the counter. There the 19 goes to the list, and I increment the counter. Compare the 21 and the 20. The 20 go to the increment the counter does not work. Okay, so I should have stopped now. Okay, so a big flag, if you are done with the first list, stop. But what should you do? Easy peasy. From the longest list, copy all the remaining elements. How do I copy something in the list? You know, you've done it in the previous class example. You have to remember you have a special counter in that new list, and you have to increment every time you copy it to it. How did your general plan go? If you do not understand what I've done now, you have to quickly rewind and relook at it. You need to understand the idea, the general plan. Let's make it a bit formal. We say we have 3 lists. Now I'm linking my diagram to what I've said before. List 1, list 2, list 3. We say we traverse list 1 with counter I, another counter j, and a counter k. We have input those two lists. Of one is a calling list and the other one is a parameter list. And we have the return list, our output. And let's see if what we've written here under processing more or less resembles what we've just did. Repeat the following process until the end of one of the arrays is reached. You know why. Compare the data elements at position I. I is what I had at the arrow in that list, and position J. J is my arrow in that list. Add the smaller of the two to the new array and increment the new array's counter k. You continue with that until you reach the end of this shorter list, and then you copy the rest of the longer list. How close were you? What were your steps? Can you see mine resembles already a little bit of Java? Before we start right down the steps, let's take a break. You have to be on board at this stage before you look at the next video. You know the story by now. The previous slide is now here. We don't want to forget that, so we keep it in mind there. But you know all about it, and if you do not understand that diagram, go and watch the previous video. Now in step 2, we have to write down all the detail. So, the first item, identify the data structures in terms of the calling array, the parameter array, and the return array. You know that this list 1 is the calling array, list 2 is the parameter array, and list 3 is the return array. Can you write down the call of the to the method now? And the heading of the method? Quickly hit pause, do so, and check if you are right. Please try this first by yourself. First of all, you have to understand by now that the call is in the test class, and the heading is in the myArrayList class. Yes, you have a myArrayList which you return and a myArrayList parameter there. So you are using objects of the same class as parameters. That's what the study unit teaches you or demonstrates. And I just added here for the ease of reference that we are going to use it to call the variable or the object which we return. We are going to call it return array. And now I ask you to write down the steps. So I'm going to ask you to go back there and write that in more programming-like steps, but not quite Java yet. Have a go at it. Pause, have a go at it, and come back when you have steps. If you don't know what to do, go into the previous class example just to get the hang of how to write steps. Your steps need not be like mine, not at all, but it must have the same idea. I say use 3 counters, I, J, and K for list 1, 2, 3 respectively. Bang, there they are. But I'm writing it down now. Use a while loop until any list is completed. And then I don't want to go to compareTo here because it's not necessary. That's why we write this in normal steps. Otherwise you get totally lost in compareTo. And if you write these ifs like this first, then the compareTo becomes very easy later. So if this, which is the calling array, position I, is smaller than the parameter position J, position I is smaller than position J, take position I and copy that in the return array, where at position K, And if it's not smaller, what does it mean? It means, yes, you're right. You have to take position J. You have to take position J to that variable. And you have to increment J. Did you notice that you have to increment I? Now you have to increment J. How close were you? Did you notice how the previous slide where I drew the arrows actually gave you the hint of what to do. And if you can understand that moving forward through an array is incrementing a counter, you will notice that you can break all these things, all these questions down to moving through arrays, traversing arrays, and comparing values. Okay, let's continue. But we are not done yet, because what happens if the one array is longer than the other array? You have to copy the rest of the array. So we have to copy the array that's not complete into the return array. If you look at our example, remember though that back end of the parameter array, I copied in there. But there's something very cool. Where do I start? I start at the current value of j, and I copy it to the current value of k. So I just continue with j, and I continue with k. That's very cool when we do that in Java. Okay. And the same as in the previous example, this value of k is actually the size of the return array. So I can set the size of the return array to the value of k, and I can return the array. I have to set that size. Size is not set automatically if I just put data in. Remember, I did not use the add method. I could have used the add method, but that add method is order n. So then this could have been order n squared as well, and I didn't want to go there. Okay, let's take a break so that you have time to re-watch this before we look at the special cases. Let's continue. I hope you wrote the special cases by yourself down. If you have not, quickly pause and do so. You've guessed it. The arrays can be empty. Any one of the calling or the parameter array can be empty, or both. And then the fourth one, I wonder how many of you figured that one out. Remember, the third one is double or is the combined length, and it can be too big. We can go over 100 or math elements. Let's quickly have a look at the solutions. If the calling array is empty, what does it mean? That one is gone, it's empty. What's the answer of the merger? It's the parameter array. If the parameter array is empty, what should be the result? You've guessed it, the calling array. Okay, what's the third one? Both arrays are empty. Then what should we return? Nothing. But it's okay, we can just return the calling array or the parameter array, so we don't have to do anything special if both of them are empty. The previous ifs will cover that as well. And number 4, we can raise an exception and say, no, you are out of bounds here. Or we can return a null value for the array. But if we return a null value, it must be checked every time in the test program. So we are not going to do that. We are going to go through for raising an exception. Okay, so now you can put it together everything you've done again. So you have done all the hard work, and now you can simply write the Java. And before last week you thought you are not good at Java. And all of a sudden you are realizing that your problem is not Java. Your problem is developing this part here. And now that you are better with it, your Java is getting better as well. So I want you to pause now and see if you can write this method all on your own before I start explaining. Let's see how you went. First of all, the heading. The heading had this. Oh, did you remember that? The generic. Yes, we have to continue with the E. And I like all my variables to be initialized before I start. So my counters and my return array. Please notice that I'm moving the code which we have explained there to the top. Now I'm doing the special cases. I say if this, which is this and which is param. This is the one who called the method. So you can see there, list.merge1, that would be this one. List.merge1, this is why I say list1.merge, list2. Then that one is the parameter. If you look again, it will go there. And this one is the calling array. And in the program itself, it is this variable. Allow yourself to understand this perhaps for the first time. The calling object is this variable in the class. So this code here, if this dot get size, I'm referring to this blue array here. If this get size equals 0, I could have said if size is 0, return the parameter array. This is what we've done here. If the parameter array, where do I get that name parameter from? There, from the heading. If that size is 0, I return the calling array. Can you see that the word this contains the entire object? Okay, and now my special case, number 4, the resulting array is too big. So if I get the size of the calling variable array and I add the size of the parameter array, if that is larger than max elements, I'm out of bounds. But luckily I can kind of create my own clever error message here. A challenge. Quickly see if you can understand why number 3. For number 3 we don't have to put any additional code. Because if any one is here is empty, if both are empty, the list 1 is also empty, then this if would be done first and the right thing would happen. There will be a return. So we don't require any additional action. Are you still with me? If you are not, rewind and listen again. Now we are going to go for the body. We are doing two things. We are copying it until we reach the end of one list, and then we are copying the rest. So let's just go for the part where we reach the end of one list. Use a while loop until any of the lists are completed. While EI, which is 0, is smaller than this get size, and J is smaller than the parameter. So I'm checking, and it must be an and. Both must be true. I should be smaller than the size of the calling array, and J should be smaller than the size of the parameter array. Now I compare those two values. If you do not understand that, come here. This is what I really do. But I cannot do that. Why not? Because it's generics. There's a nice explanation in the previous session for that. So I'm calling compareTo. Where is the compareTo that will be executed? I don't want you to say in the integer clause. You are right, but I don't want you to say that. You have to tell me in clause E, because it depends who is using the array. Okay, so let's say that if is true, which means that data I is indeed smaller than data J, that data I, that one is indeed smaller than that one. Here's what do we want to do? We want to add data I to the return array. Increment k is the value running in the returning array and increment the pointer in, or the arrow in the first array. And if it's not, we want to take the parameter data.j to the return array and increment j. See, we don't increment I. If you don't understand that, go back to the beginning of the video, where I drew the arrows, where I was talking about the general process. Okay, now for the second part of the copying. Now we ran out of elements for one of the lists. For the first time, we have to figure out which list we ran out. This is why you have kind of identical code here. If I is smaller than get size, it means that there are still elements in I. If j is smaller than get size of the parameter list, there's still elements in j. And so in this case of our example, that one will be false. Do you agree? We will do this code. Because we ran out, I have reached for the size of it. But that is not so important to understand now. The idea is we check every list to see if it's smaller than. Okay, now look at the 4. What is funny? What is extremely funny? What's even funnier than funny? I say, where must I start? I should start at the current position of I. Or in the second case, where must be j start? J start at the current position of j. You could have just put a semicolon there. Java would accept it, but it's so cute to say for I equals I, that I just leave it like that. Why? I'm not changing the value of I. I'm continuing where I left off with the I value. And I just copy all the data in there until where? Until size. So the rest of the data is copied into the new array. Remember to increment the k value, otherwise you copy it on the same place, same place, same place. You want to go to the next place. How did you go? How much would you give yourself for your program? Not a lot if you forgot to return the array. If you do this little bottom here, we still need to return that array. But that array should be a proper my array list. Therefore, it must have a size variable. And what is size? Size is equal to k. If you do not know why, just do it by hand. Write down the values for k all the time, and you will see that it's indeed right. And you return the array. Can you imagine? Look at that long program. More than 50 lines of code. And you thought you could not program Java. Are you proud of yourself? You have reason to. Now the art of a test method. So we are going to test it. But luckily you know what I mean. Test all the special cases. I know I can see you just grabbing a pen to write the Java. Keep doing it. Test all the if statements. So my mind says that one can be longer, that one can be longer. We have to test both cases. Give clear output statements and use proper coding. What must we test? Let's recap. We have to test all the special cases. We have to test if the calling list is shorter than the parameter list, and the other way around, and we can even test if they have the same length. Pause quickly, pause, don't look, pause, write your own. Welcome back. Remember what I said last time. Let's put our program there so that we know we do everything. I need 3 lists. If you don't know why, go back all the way and listen again. But before you do that, go through the code. Perhaps you will get to know the answer. How do I call this method? list 3 equals list 1 dot merge. This is the parameter list, this is the calling list, and that's the one that returns things back. What am I doing there now? I am in fact calling it with both lists empty. List 1 is empty, list 2 is empty. I just created it. And I have a sequence of prints here so that I can properly see what's going on. Okay, so this is my first test case. I have tested that. Bam. I'm testing it now with a parameter list empty, so I'm adding items to the calling list. So I'm testing it with only the parameter list empty. And now I'm testing it with a calling list empty. Okay, but this is, remember at the beginning of the previous session, we introduced a clear method. This is why I've done it, so that we can clear our list here. Clear sets size equal to 0, so we wipe the entire list by just setting the size to 0. So we clear list 1 is empty, and we add stuff to list 2, and so we are testing that one properly. The calling list is empty, and the parameter list has values. Okay, so now we've tested those first two ifs. We are not going to do this because we should either add 100 items or we should change that max elements variable to something else and just like in 2 and test it, but you can do that. You know how. If you don't, and if you desperately want to, ask in the chat room. We will help you there. Okay, we sort of tested the the special cases, so we can tick that part of the program. Now we have to test it with a calling array which is shorter than a parameter array and the other way around. So let's first test it with a calling array shorter than the parameter array and directly after the calling list longer than the parameter list. So I clear both arrays in both instances. Then I add the list 1, I add only 2 numbers. Can you see? I only add 2 numbers to list 1. I add 4 numbers to list 2 and I call the method. Tests means calling the method there. Okay, so I call the method, and do you agree that the calling list is shorter than the parameter list? And I print it to see if my answer is right. Do exactly the same thing. Clear the list, add more to the calling list than the parameter list because the calling list is now longer. Call the method. Now just for the fun of it, I call it with equal sizes. And every time I print all the lists. Let's see if our output is right. Test 1, both lists empty. Yes, our return list was empty as well. The parameter list is empty. Yes, it was empty. It's clear there. My list is correct. The calling list is empty. Yes, my code is working. The calling list shorter than the parameter list. Is this code right? Quickly check those values. Yes, it's working. And the calling list longer than the parameter list. Now output there. Let's have a look. Didn't I put code? Oh, I will fix this. It's just a matter of did not put the printouts there and equal sizes. Please go to the folder for the code. It is in resources under class example 2, and then you can run it to see how this actually works correctly. Now, if I go to the next slide, there's a surprise waiting for you. You have succeeded. You are now a master, a fool to understanding generic arrays. You can score 20 out of 20 in the exam and the tests. This isn't that hard. Look at what you have achieved and listen to the videos and again and again and again until you get this right. Enjoy the rest of the week. Good luck with the class test on this, and keep your eye open for the assignment on this work.